Hi everyone, this is video 3 for section 1.3, reasoning and logic. So in this video, we're moving on to talking about different forms of the conditional, right? So the conditional was what we just talked about up here, right? This if then, or if P, then Q. So this is the conditional statement. So there's different forms of this conditional that we're going to talk about now. So the original version, right, is represented by if then P, then Q, but we can also write it as so this if P, then Q, and words can also be written as P arrowing over to Q, because we know if P happens, then Q has to happen. So it's represented like this. Okay, so there are different forms of this conditional where we negate things and we switch around the P's and Q's for the converse, inverse, and contrapositive. So let's look at this statement. So if Zeke is a cheater, so that's going to be our P is Zeke is a cheater, then we know that Zeke sits in the back row. So that's going to be Q. So, right, the normal form is P implies Q. So now let's go through these other forms. So the first one is the converse. So this one, how I remember this one is, well, I'll get to that in a minute. We're just going to write it down and then I'll tell you how I remember all of these. So the converse, you just switch P and Q. So I think it's really easy to think about these things, not in terms of the statement, but just in terms of these symbolic representations of the converse is, you switch and say that Q implies P. So this is going to be written if Zeke sits in the back row, then he is a cheater. Okay, so that's the converse. So the next one is the inverse. So this one, instead of switching the position of P and Q, we're going to switch the truth value by negation. So this is not P implies not Q. So this little squiggle, it's in your textbook on page 26 in the margin. This is the same thing as not P. So I'll write that as a note up here, where not P is logically equivalent to, it's the same thing as this little squiggle P. So this is the squiggle that it's on your keyboard on like your computer, right before the 1. It's usually right in there. So this inverse, instead of switching the positions of P and Q like the converse, we negate them. And so this one says that if Zeke is not a cheater, then he does not sit in the back row. Okay, so the next one is the contrapositive. So this one, this is the longest word. So we take, so the contrapositive, we do both of the things that we just did. We switch the position of P and Q, and we negate them both. So instead of P implies Q, we're going to have not Q implies not P. So this one is kind of the most complex just because you switch the positions and you negate them. So we write the contrapositive like this. If Zeke does not sit in the back row, then he is not a cheater. Okay, so these are the different ways that we do the things. So now I'm going to tell you how I remember this. So you remember be the expression that, well, I guess let's think about negative numbers, right? Because it's negate sounds a lot like negative numbers. So you know the concept where if you take minus 3, that those two negatives will cancel, and this is the same thing as 3. So this is actually how these forms of the conditional work. We have that when we combine the operations of switching the position of P and Q and negating P and Q, we get that the contrapositive is actually, so not Q implies not P, is actually the same thing as this original conditional P implies Q, right? And this exact same concept of, well, we know that when we just switch them, it's not the same. When we switch P and Q, it doesn't say the same thing. We also know that when we negate them, we negate P and Q to get the inverse, it doesn't mean the same thing. But whenever we do both, we actually end up getting exactly the same thing back, just like how these two negatives will cancel to get us back to the 3 that we had originally. So these things are logically equivalent. So a way that I remember kind of what these do is to think about just the words converse and inverse themselves. So converse, the first thing I automatically think of are the shoes, right? Converse shoes. So you have your Converse shoes, and it's really easy to get your shoes mixed up and put the wrong shoe on the wrong foot, and it'll go in, but it doesn't fit quite right, right? Our shoes fit much better when the right shoe is on the right foot and when the left shoe is on the left foot. So whenever you switch your shoes, something's not right. Just like whenever you switch P and Q to get Q implies P, something's not quite right. That's not the same. Similarly, a way I like to think of the inverse is inverting the colors on your phone, right? When you invert the colors, yeah, you can still read your phone and see what's going on, but something's not quite right, and it's just not the same. So that's how I remember converse. You can switch your shoes to the opposite feet, but inverse is like inverting colors, right? Inverting colors, making things the negative color, like you can do on your phone or your computer or something like that, is how I remember these. So I guess the biggest takeaways from here are that what the converse, inverse, contrapositive are, and that the converse and inverse aren't the same as the original P implies Q. They're a little bit different logically, but the contrapositive is the same. Okay, so now this last one that we need to do is the biconditional. So the biconditional, it's a lot like the conditional, but it goes both ways. So we have P implies Q as one conditional, but we also are going to combine it with the converse, Q implies P, and we need both of those conditions. So this is written with a double arrow because we need the arrow to go both ways. P, if and only if Q. So that's, instead of if then, it's going to be an if and only if. So the way we're going to write this for this statement is Zeke is a cheater if and only if he sits in the back row. So that's our biconditional. He's a cheater if and only if he sits in the back row. So this means that if he's a cheater, well, then he has to sit in the back row, and if he sits in the back row, well, then he has to be a cheater. It combines these two original P implies Q and Q implies P. Okay, so one thing I want to talk about before we move on to the next topic is how we do the truth tables of the conditional, just because, again, this is really complicated and a lot of people get confused on this. So I'm going to write a little truth table right here for us just to talk about. So remember, everything's always set up the exact same way. P is true, true, false, false, and Q is true, false, true, false. Okay. So let's talk about when these the truth values of these things. So again, a really tangible way to think about these things is to think about when someone is lying to you. So the book has an example of this in example 7, but I'm just going to give you another one. That example 7 is on page 26. So I'm just going to give you another example of how this works. So let's think about if someone told you, if a parent told their kid, if you do your homework, then you get a cookie. And let's evaluate when that parent is lying to their kid. So if they indeed did their homework and the parent indeed gave them a cookie, this true situation, everything works out exactly like we thought it would, right? Everything's hunky-dory, everybody's telling the truth, everything works out. So now imagine the scenario where the parent said, if you do your homework, then you get a cookie. Well, the student or the kid did their homework, but the parent didn't give them a cookie. Well, in that case, they're a big fat liar, right? They said they were going to do this thing and then just didn't do it. So that's false. Okay, it's false because they were a liar. So let's go to this next one. Well, in this situation, the parent said to the kid, if you do your homework, then you get a cookie. And this P is false, which means that the kid didn't do their homework. Well, do we know what's supposed to happen in that case? The parent said, if you do your homework, then you get a cookie. So the parent didn't say what would happen if the kid didn't do their homework. So no matter what, because the parent didn't make a statement on what would happen if the kid didn't do their homework, by default, they have to be telling the truth because they didn't say what would happen if their child didn't do their homework. But no matter what happens, they're not lying because they never said what would happen in that case. So this is what we call vacuously true in these two cases. So this is vacuously true. These two right there. So yeah, it's called vacuously true because it has to be true for no other reason than we didn't say what would happen in that case. So this is kind of a special case, and this confuses a lot of people. So make sure you read the book and rewatch this video a couple times if you need to see why this works the way it works. Okay, so the last topic for this section is direct and indirect reasoning on page 27, and we're going to look at if arguments are valid or flawed. Another way for us to say flawed is invalid. It's the same thing. Okay, so we have these arguments like so. So we are given these statements, right? We're given an if-then statement. We're given what happened and the conclusion that we made. So if Jules solved this problem correctly, then Jules obtained the answer 2. So rather than look at these with all the words, just like when we wrote here above, right, the different forms, it's easier to just kind of think about this in symbols because you just don't have to deal with all the other things. So let's look at this first if-then statement. So we have if Jules solved the problem correctly, so we're going to have that be our P, then Jules obtained the answer 2. We're going to have that be our Q. So we can identify the rest of the argument this way. So the next line says Jules obtained the answer 2. Well, that's just the same as our Q. And our last line is therefore, Jules solved this problem correctly. Well, that's just the same as our P. So we can write this symbolically as P implies Q, and then Q, and then the therefore gets translated into these 3 little dots. This is just the symbol for therefore, and therefore P. So we know that P implies Q, and we know that Q happens, and the conclusion we made was that Q results in P. So like we just did above, we know that Q implies P is the converse. So does that make sense? If we know that P implies Q, does Q imply P? Well, if we have our Converse shoes and we put them on the opposite feet, well, that doesn't quite work, right? So this is a flawed argument because the logic they had was that if we knew P implies Q, then we also know Q implies P. And we know that that's not true because those things are not logically equivalent. So this is a flawed argument. Okay, let's go to the next one. So again, we start out with an if-then statement. So again, we can identify a P and a Q. So this number being larger than 2 is P. Well, actually, sorry, before we go on to this one, I just want to point out kind of why we know the converse isn't the same. So I can tell you this thing about putting your shoes on different feet, but you can also just kind of think through it yourself. So let's look at this example. We know that Jules obtained the answer 2, but think about this. Does that mean that Jules solved the problem correctly? Well, all of you want to be teachers, and you should really know that if a student gets the correct answer, that doesn't always mean they solved the problem correctly. They could have done the wrong work and made steps that were incorrect, but that ended up getting the correct answer. It's kind of the same concept of if someone gives you directions to their house and eventually you get it to their house, but you got lost along the way. Well, you got to your destination, but you didn't follow the route that they gave you. It's possible to get to the end, but getting there a little bit differently than you were supposed to. So that's another reason you can just think through of why this is a flawed argument. Okay, now to this last one. So if this number is larger than 2, then its square is larger than 2. So again, we're going to identify a P, the number being larger than 2, and a Q, its square being larger than 4. Okay, so now the next line is the square is not larger than 4. So we know that this is really similar to Q, but it has a not in there. So it's going to be not Q. And the last line is this number is not larger than 2. So it's really similar to P, but there's a not in there. So it's not P. So again, we can just write this out symbolically. So our first line is P implies Q. Our next line is not Q. And therefore, we conclude not P. Okay, so this again is saying we have not Q, and we want to say that it implies not P. So this, like we did above, this is the contrapositive. Okay, so remember that the contrapositive is logically equivalent to the conditional, right? Because we flipped their places and we negated them. It's the same thing as doing a negative twice. We end up with the same result. So that means that this is actually a valid argument because we took the conditional, P implies Q, and we concluded the contrapositive, not Q implies not P. And since those are logically equivalent, this is a valid argument. Okay, one thing that I want to say about these different forms of the conditional before we stop this video is that you can always check these. So this statement that I set up here, this not Q implies not P is the same as P implies Q. You can check that on your own. If you still feel a little iffy about it, that you just don't believe it in your gut yet, you can check that that is indeed logically equivalent. And you can do that the same way we did right up here in this example, right? We verified these two things being logically equivalent using a truth table. And so we can do that exact same thing with showing that the contrapositive is logically equivalent to the conditional. So if you want to do that just so you believe it, go for it. And you should get that they're the exact same. And if you don't, ask me about it and we can work through it together. But in the meantime, that is all for section 1.3. So you should have everything you need now to go ahead and do the homework. And if you need anything, like always, feel free to email me or come to office hours. But that is all for this video.